The topic of this video is on the intercepts of rational functions. So I can tell you before I start here, there is a slight typo. Let me get rid of this. So there should be a minus sign right here only, just a minus. All right, so this function is graphed, and so we were trying to find the connection in class about where the x-intercepts come from and where the y-intercept comes from. So you can see that there are two x-intercepts. Those include -2 and 3, and the y-intercept in this case is -6. And so one thing that we wanted to bring back here is that if we write down like the actual coordinates of these points, it's -2, 0, and 3, 0, and at the bottom here, this is 0, -6. And one thing that they all have in common is that their other part of their coordinate is a 0. So when we are finding the x-intercept, we are essentially finding the x value when y equals 0, okay? And when you think about when can this function equal 0, and that's when the numerator equals 0, because it can't be 0 over 0, because we can't have 0 in the denominator. I just said 0 a lot of times, sorry. But if the numerator is 0 divided by any other number, that's always going to produce the answer of 0. So what we decided to do was we are going to set the numerator equal to 0. That's not what I meant to put. 0 and solve. Okay, to solve, you're going to have to factor. So this ends up being x minus 3 and x plus 2 equals 0, which then leads the x equals 3 and x equals -2, which is exactly what we got. So perfect. The other thing on the and the last thing I guess we would say about this is that we did decide it is possible to have no x-intercept or septs. Like it was possible to have a numerator that could not equal 0. The example given was 2 over x. We can't make 2 equal to 0, so this isn't going to have an x-intercept. On the y-intercept path, it's kind of the same idea. It's the y value when x equals 0. And to do that, you're going to plug in 0 for all x's, okay? I think the best way to do that is to plug it into the original and not the factored form. So essentially this would be 0 squared minus 0 minus 6 over 0 squared plus 2 times 0 plus 1. And what you'll notice when you plug into this form is that all of this has no impact because it's just going to equal 0 and cancel out. So the only part that matters is the end, which is this. And that ends up being -6 over 1, which in this case is -6, which is where that comes from. Okay, so when you plug in 0 for all the x's, get rid of the things that cancel, and then simplify whatever's left. Again, we said that it is possible to have no y-intercept. And this example right here is another case of that, because if we plug in 0 into this equation, we're going to get an undefined function. So if the y-axis is the asymptote, or if there's a hole on the y-axis, that's going to create no y-intercept. So let's practice a few. In this case, if we were to find the x-intercepts first, we need to factor both still, because if something is a hole, it is not considered an x-intercept, so because that's a hole. So we still need to factor both. So in this case, it's x minus 3 and x plus 1 all over -4 and x plus 2. There are no holes, so we're setting the numerator equal to 0. So in this case, I have an x-intercept of 3 and -1. When I go to do my y-intercept, I'm plugging in 0 for everything. And when I do that, this whole part cancels. And that leaves me with -3 over -8, which simplifies to 3/8. All right, let's look at the second one. So x minus 4, plus 2. And below it, x minus 2 and x plus 1. No holes again. My x-intercepts are 4 and -2. And my y-intercept in this case is, let's see here, because all of this is going to cancel. And -8 over -2 is 4. On the back side of this paper, there are 4 practice problems, which is what we finished in class today, that I'd like you to try. I'm going to go to a different document because I have the answers written in there. But I want you to kind of look at them and then see, compare, maybe not. Hold on. It's this one? There they are. Go ahead and try those on your own and see if if you end up at the same place. And if you don't, or this was confusing, please, please, please come and see me. Don't hesitate to ask questions.